Hey, it's John McBride, RMUS. I'm the VP of Technology here at RMUS in the United States, and today I'm joined with Kevin Totterall up in Canada. Our RMUS, he's my sidekick up there doing all the fun stuff that they do up there. We're doing another presentation for RMUS Tech Week, which, again, we're just given that ability for everybody to kind of understand the technology out there, introduce you to some of this technology, as well as the people that are behind the scenes making this all work. And today we have a really special guest, Bobby Watts from Watts Innovation. I will selfishly say, I will say it quietly, that I was a fan of Bobby Watts for the longest time because he's also a championship RC helicopter guy, if you did not know this. So, you know, for me, being an RC guy, not very popular in the RC world, and watching Bobby do RC stuff and flying around was absolutely astounding. And now he's taken this right into the engineering side of things, so definitely an engineer creating and making the Watts Prism. Let me get out of the way here. So, right here behind us, the Watts Innovation Prism, a new ship out there. He's already been kicking butt, you know, making other versions, but now has created his own whole system, an X8 version, X4 version, has his own remote that he's running around out there as well, and we're going to learn a lot about it today. Also, we're going to be talking about, like I said, the majority of it is the engineering side of things, so we're going to get a little techie with this presentation today, but first I wanted to talk to Kevin and kind of just see what the world is thinking up there in Canada as far as the Watts machine. So Kevin Totterall, again, my counterpart up there at RMUS Canada.
So hello everybody from the Great White North up here. Thanks. Good to be here again with you today. I'm very excited about this session and this aircraft. You know, we Canadians we're a humble and kind of a show me people. And well, it's exciting with all these new platforms out there. There's a lot of these ones are hype, and everywhere you turn around on LinkedIn, there's a new post about how awesome they are. But then, you know, you don't get to see what they can actually do. So this, to me, this is a meat and potatoes aircraft. Bobby is a meat and potatoes kind of person. They're not about hype. They're about delivering. And it's an exciting platform that's going to lead to some opportunities in these bigger platforms. And let's face it, there's lots of small suppliers now for small aircraft, but there's very few for the bigger ones that you can trust. And there's still lots of applications that will require bigger or different payloads. And so, you know, obviously up here we have a lot of this for you know, fire detection, gas detection, corona detection, specialty, you know, public safety units. So all of these things are something that that we're excited to see on this platform. So, John, I can tell you, I can't wait. I'm excited to see Bobby get into it today.
Yeah, me as well. I mean, like I said, it's kind of refreshing to kind of see this new development, this new creation, and, you know, not, I wouldn't say a whole huge company trying to accomplish this. You know, we already know the difficulties in trying to make stuff. I mean, to emulate and recreate and start from ground zero to then work with so many different manufacturers. So, you know, it is a trial, definitely some fall down, some pickups, and, you know, we're here to help out that, you know, to get the ball moving along with Bobby, and as well as all of the other manufacturers that he's currently trying to work with to get these solutions, if you will, figured out there in the market. So without further ado, let me introduce Bobby Watts. Like I said, great guy, great person, and he just got himself a brand new microphone, so let's hope he looks good on screen here. Here we go, Bobby.
Oh man, no pressure. How's it going? After that intro, I'm speechless. I don't know what to say. Thank you guys so much for the kind introduction. And I mean, man, everything that your team at RMUS have been doing so far, you guys have been amazing to work with. So thanks so much for having me on. This will be awesome.
Yeah, like I said, I think the world has been kind of waiting for this. You know, there is competitors of yours out there. There's no doubt. Every company has them. You know, so but overall, you know, trying to impact a heavy lift drone, doing the jobs that you're doing now, also integration and not just carrying things. You know, we've got a lot of stuff. So I'm sure you're going to talk about it today. But I wanted to show a really cool video that we made. This is our production. My fancy guy Jace, who always forgets to unmute me and as well, needs to make sure I look good on camera. Let's go ahead and play that video, and we'll just kind of talk about it, because like I said, it's not nearly as cool as just sitting here behind me. So let's go ahead and hit that, Jace. So again, the development of this and the creation of it, FPV camera up on the front end, the way the arms are designed, and again, Bobby's going to take us through this a little bit more. And I don't know if you wanted to talk a little bit about this as well, Bobby, just kind of what we're seeing here. We have the inspector package. I don't know. It's a cool video, yeah?
Yeah, absolutely. You guys nailed it with this one. So this one, I believe you guys have your inspector package on there. This is showing a lot of nice close-ups of our CNC work and some of the data connectors, power connectors, the gimbal itself. Yeah, this is the coaxial X8 variant. So this one can fly at all up weight of 55 pounds. And you guys just nailed it. That's such like an inspiring video right there. It just looked awesome.
It's a short one. Don't beef him up too much. Jace already gets enough from me, So,
There you go.
Yeah.
Okay. No, that one's awesome.
Yeah, it's great, and like I said, the creation of it we already know it can be very complicated. But you're going to kind of walk us through this development, this creation, and again the time and understanding. I think a lot of people just don't quite get that. They just want to get the equipment out there. Why is it not here? What's going on? It does. So maybe you can talk a little bit about that. Some of your challenges.
Yeah. I mean, sure, and any response I give in the next 2 minutes doesn't quite do it justice. I mean, we just have a saying here, just drones are hard, and it's really challenging. It's really, really challenging to manufacture anything. So I even find myself wondering, like, how do they manufacture Post-it notes or paper clips? And I look up to those manufacturers as like, wow, those guys are like, that's a really hard problem to solve. But then when you're trying to make a computer that flies, it obviously has its challenges. But yeah, I mean, with Prism, like what we wanted to do, what I really wanted to do with this was just make an aircraft that would be, you guys called it earlier the meat and potatoes aircraft, and that's what we wanted to do. I want this to be the Ford Explorer, if you will. Just like a really solid aircraft that just works, that hopefully people will be flying for many years, and it literally just works. We literally went back to the drawing board and just made zero assumptions when we started designing it. And the design itself took, I mean, through the pandemic and everything, but it was at least about an 18-month design time. So we had many prototypes flying in the process, and everything done in CAD. And we really spent a lot of time on it. But I think we came up with some really cool technology that I've never seen done before. And it's working. Like this new tech that we've developed is actually, like, our customers are using it out in the field, and it's just really exciting to see. And so, like our build team right now has another 5 up on the build queue right now, and they're cranking away. So it's just been amazing so far. It's been met with great reception, and so yeah, I'd love to talk to you more about the technical aspects of it today. So yeah, just awesome stuff.
Yeah, so we, like I said, I mean, my experience so far with heavy lift in general, this goes back 15 years or so, and I know you, having a lot of RC helicopter experience as well, and kind of, messing with those airframes, throwing cameras on them, trying to get these things out there. We didn't have a lot of options in that heavy lift area. As soon as the, I would dare say the M600 came along, that really made it easy. It made it easy for myself to then put payloads on there that didn't require a whole lot of, fiddling around with the flight controller and messing around with parameters there. And we've discussed this many a time, about kind of working through how it should behave in the air or what it should do. And correct me if I'm wrong, I mean, we're using a Pixhawk based system, basically an ArduPilot, a cube, if you will. And this tends to have, the same qualifications of anyone else that has that, but you've got special sauce built into this. You've got, on that technical side of things, you've done a lot of things that really make this proprietary to you on how you've designed it, how you are working with the Pixhawk itself, and it's not it's nothing that anyone else can really copy very well. Would you agree?
Absolutely. I had my first introduction to the Pixhawk, and oftentimes you hear the Pixhawk being thrown around. And basically, what the Pixhawk is there's two different types of firmwares that run Pixhawk, if you will. There's what's called RGPilot and there's PX4. And on Prism, as this version is, this one's running on RGPilot, the RGCopter firmware, and the hardware that runs that is called the Cube. And this cube in this case is a orange cube. And so I started using that about 4 years ago, and I hated it. Absolutely hated it. I mean, I even remember writing a post on LinkedIn, and I shouldn't have done it, but like just not happy with it because I was coming from the DJI world where everything's kind of plug and play, and you slide the gain for more gain and you slide it down for less gain. And the thing about the Pixhawk is it's not a direct replacement for like a DJI autopilot. If you put a Pixhawk in your aircraft, you are accepting the challenge of basically creating your own flight controller. Now, the RGPilot and PX4 community have done an amazing job with the RGCopter firmware itself. So you're already 95% of the way there. But the really hard part that I found was the interface with the user. And it can do everything. Like this can navigate a car or a truck or a sub or an airplane. I mean, this can fly anything. We could use a cube on a propeller test stand and measure vibration levels. Like you can do anything with it. But because it's so powerful, it's almost overwhelming to a user. So what we really tried to do with Prism was do as many things as we can between electrical, mechanical, and software, but then really make it easy for the user to understand everything that's going on. You make it where there's just like one button to make it slow or one button to make it fast. You click the button and drag it and it lands by itself. We built in firmware updating inside of the Watts QGC app. We have an onboard computer where we can manage different things. So I think with Prism especially, we really stepped up our game with regards to the electro software side. And that's like our proprietary stuff in there that just makes this a really easy to use machine for someone who needs, someone who's looking for an aircraft that's made here in the US that isn't DJI based, that's just easy to use. So that was really the goal with Prism.
There we go. Jace did it again to me. Jace did it again. Kevin. I got a tally mark up here on shutting me down up here. I'm telling you. Anyway, so as far as the software goes, Bobby, I mean we're not unfamiliar with this ecosystem, but to raise the bar in that ecosystem, obviously you need to then do a lot of integration with other manufacturers to include not just the hardware, but you do have a level of hardware that needs to be understood as well. So when we're talking about radio systems that have to be there, propulsion systems that have to be there, any FPV integration, all of these things are kind of special in some manner. And even though some people could do it, like you said, it's not really easy. Twin GPS system here.
Drones are hard.
Yep, I got a couple batteries that we've got, even though these aren't necessarily smart batteries, but being able to kind of bring this all together, and we're only talking about the systems that we're looking at this moment. But now, we've got to throw gimbals on it, made by somebody else. We've got to throw a camera on there, made by somebody else. We want to have control of that camera. We want to change the settings. We want to change the aperture. We want to change. Man, this can be very challenging. I would say. So, honestly, because I know your experience in the cinema side, helping cinema guys and LiDAR people, they literally don't have much to communicate to the drone. I mean, there isn't much they need to talk to. Would that be fair to say?
Oh, absolutely. Yeah, right now, like LiDAR on a Prism's amazing. You just give it power, you turn it on, and you go fly. Like a LiDAR is basically plug and play. Same with cinema. Cinema runs completely separate radio systems for the gimbal and the camera versus the aircraft. But you're absolutely right. There's a lot of integration between the sensors and the aircraft itself that needs to take place. So that's why when we developed this, we developed Prism as more of a platform. And we just tried to follow all of the standards that are out there now that in our opinion are, the most popular standards. And then so long as the gimbal manufacturers, camera manufacturers, everyone makes their products to those standards, then we won't have a problem. And it'll basically be a pretty close to plug and play experience with Prism. Now, what the market is seeing is that getting your product to work to these standards isn't trivial. It's pretty difficult. So that's why we're seeing a race between gimbal manufacturers, camera manufacturers, different sensors, trying to get everything working with this one protocol, which in this case is called MAVLink. So everything is speaking by this language, basically, that's called MAVLink. And so I think that's where the industry's having a little bit of difficulty. I think the rollout is slower than everyone wanted, but we're seeing some really good progress by the larger camera companies and gimbal companies to where in a very short amount of time, everything will just basically be plug and play with our system and anyone else that's using a RG Pilot or PX4 system.
Yeah, I think that's definitely trying to push this, standard as you call it has been very hard. I mean, DJI, you had mentioned them using their flight controllers. They have their standard. If you don't follow along with their standard of API protocol, as well as any of their SDK, onboard SDK protocol, that is their standard, and theirs alone, So manufacturers that are making sensors, gimbals, or anything else have to coincide with that. So hopefully, with an open source product like this, the Cube and others, that we can see this. We can start seeing this development, and it won't be so complicated for people like yourself, as well as possibly others, to go out there and have the MAVLink being the common protocol that everybody talks on or does, as far as controllability. So, Kevin, did you have anything to add to this? I'm just kind of hanging out. You're just creeping in the background. That's all I see back there.
I think it's great. It's a platform, and thanks, Jace, for keeping me unmuted. I appreciate that. I think there's one thing. So we talked about Bobby, building this as a platform. So I think that's an important thing. Maybe we're bearing the lead a little bit. So there's some really kind of cool modularity, transformability. So talk about the design factors that led you to build this. Like, why did you choose those batteries? Why do we have like an option for coaxial versus a quad? Talk about that and what it'll enable our end customers to actually do on the implementation side.
And that's a really good question. I'm glad you asked that. That's an excellent question. So basically, why did we make a machine that can fly as a quadcopter at, a weight of 25 pounds or maybe 30 pounds, all the way up to a coaxial X8 that flies at 55 pounds? And the answer is really quite simple. As a small company, that's trying to catch up and gain market share and get our products out there. We have so many fires that we need to put out at one time, and a million products that we need to develop to get out in the market. And so the question is, how do we do that, and how do we use our time in the wisest way possible? And so for us, if we were to design a machine that weighs 5 pounds and flies around and maybe a little bit bigger than a Mavic or something, that would take us about 18 months. If we were to develop a machine that flies at an all-up weight of 500 pounds, we could have something flying in about 18 months. But I can't do both at the same time. It's very hard. So what we did with Prism was we tried to find that happy medium where we could create a center structure that's light enough to fly as a small quadcopter, but strong enough to fly as a coaxial X8. And the idea is to be able to provide the customer with a machine where they can fly a 20-pound camera or LiDAR package or something like that and use the coaxial X8 arms. But then also that same customer, if he wanted to just fly a, Workswell Wireless Pro camera with RGB and thermal, or a Flare Duo Pro R or a Sony A7, he could just throw on the quad arms, and now you have a small quadcopter. And so the idea was for us to be able to just manufacture one aircraft that can do both really well. So when we did that, we ended up creating this technology that we call Propulsion ID, which allows the user to plug in either the quad arm set or the coaxial X8 arm set, and the drone automatically recognizes the motor that you plug in and automatically configures the entire flight controller and the entire system for flight just when it detects the motors plugged in. But then this kind of trickled down in some other cool things, like each arm is user serviceable. So if you tip the aircraft over and bust a motor or a prop or something like that, you can just basically go ahead and just take take it out with 2 bolts, take any arm out with 2 bolts and replace it with another one. So it created a lot of modularity as well. So I think that that's the biggest thing about Prism is it's very modular, and it's kind of a unique aircraft out there, especially with the fact that of the propulsion ID technology. We're super proud of that.
Yeah, I think it's a great technology as well. Sorry, John. So just tell us a little bit about the batteries. So basically, it uses pretty standard hobby batteries, and there's different configurations and different milliamps that you can do depending on your payload and flight time. So tell us a little bit about what that means to an end user as well.
Sure. So for batteries at this moment in time, we're just using traditional LiPo batteries. And then there's a decent amount of algorithms going on inside that we kind of wrote to ensure that even though we don't have an onboard battery management system, we know the status and the health of your battery that you plug in. So even if you plug in a dead pack, we can still allow you to fly, but warn you, and then we give you an idea of your realistic flight time. So even though it's not a smart pack, we're doing a lot of onboard tracking of the voltage and the current, if you will, just to make sure that you're flying safely. So it's pretty basic right now. We're just really offering 2 batteries. One is the 12S 10,000 milliamp hour pack. And so that one is perfect for the quadcopter or for the coaxial X8 with a heavy payload. And so on the quadcopter, that allows you to get a flight time of, I don't know, maybe 30 minutes or something with a few pound payload. And then we also offer a larger pack that's a 12S 16,000. They got handles and everything. They're pretty large. But anyway, those will work on the coaxial X8. And those will allow you to put on a payload of up to about 13 pounds and still be under 55 pounds all up weight with a flight time of around 25 minutes. So basically any lithium battery will work, but right now we're just offering the 10,000s and 16,000s.
Well, let's, Bobby, because I'm kind of a geek and, I haven't got a whole lot of questions yet. I think we've done a good job just yakking about this the whole thing, They usually when hey, I'm just telling everybody in the crowd watching this right now, if you've got some questions, throw it in the chat. If we can help you with anything like that, now's the time. We've got both Bobby and Kevin kind of hanging out with me, so definitely throw it in there. If you have any questions, throw it in the chat, and I'll try to toss that towards Bobby on those things. But you did want to kind of, geek us out a little bit on this SolidWorks side of things, your development of, your creation of, I mean, if you're okay, just kind of, because I think, again, there's a lot of people that are familiar with that program, but not maybe so much familiar with your process of just kind of understanding, what it really is, and, we can get a little bit more technical when we're talking about this, kind of how it works and what it is, but
sure.
Yeah, let's just kind of
sure, absolutely. Yeah, absolutely. I mean, for us, we design and assemble and test fly and service the aircraft right here in the U.S. So, all of the CAD work here, we're doing it. This one's personally done by, a lot of this is done by myself, and one other engineer helped us out with this. And so we do all the SolidWorks, the mechanical design here, the software here to integrate with the open source community, as well as a lot of circuit board work as well. So to give you an idea, so we come in and we create the entire drone here in CAD, and we're able to see everything from, how all the parts are going to line up. We can see here when the aircraft folds for storage, if I can go ahead and fold the arms here. I'd fold the props separately, but, that would take a moment while we're live here. But basically, you can see how the drone comes in and locks for storage. You can even come and see we have a really cool pin system that we created that carries our power and data and our motor ID and everything like that all throughout the ARM system. So, we're designing something like this, which is the circuit board, and we're doing all the integration of how this seamlessly ties into our mechanical side. So I believe in this aircraft, we really stepped it up with electromechanical. And then that ties into software as well. But just having this here in CAD just really allows us to do just about anything with. So we get a lot of strange requests from customers of people wanting to lift various payloads and packages and drop things and winches and different cameras and whatever that might be. So because everything's here in CAD, we can just throw it in there. But I did just want to be able to spin this around for you guys and be able to show you that this is how we do it here. This is how the drone kind of comes to be.
Yeah. So in general, like I said, the challenges have always been how to design. I know I've got one of my good friends, Casey Sealock, is actually watching today. So Casey is a longtime friend of mine who is also drone guy and builds up his own stuff, 3D printer things, and whips it around. And man, Casey, isn't that cool the way Bobby just creating things on software like this, kind of seeing how all the parts and pieces get together. So, and again, high five to you, Casey, saying hi to you as well. So, Bobby, I mean, is there anything else that, that's kind of specialized on this hardware side of things that you want to talk about or kind of bring up, that you've kind of worked on or specialized parts that, that you've done that kind of make it more so than anyone else that has anything like it?
I mean, yeah, I don't even know where to begin. I mean, all I can say is like every single placement of every bolt, every wire, every pin, every screw, every piece of carbon metal. It's like pain. Like it agonizes me as we craft this into a machine. And I don't know the other word other than agony. Like if there's too many unknowns and this can go here and this can go that, like it just, I don't know how to say it other than like it pains me as to where we have to get it in like the perfect spot to where like for example like your feedback of when, like for example like when the arms close, we have an O-ring seal on the arm set that allows it to be completely dust proof and waterproof. We haven't IP rated this yet, but we're hitting IP43 standards and we could probably go get that tomorrow if I wanted to. But to give you an example, John, like we heard some feedback, like you saw there, like some of the arms were a little bit hard to press in and compress the O-ring. So to give you an example, on our second batch of units, we recessed that O-ring cutout by 0.075 millimeters. So just like the smallest little hair amount. And then now in the second one, like the folding's like perfect, like it's dead on. So we just like constantly revise this and just try to make it better and better. I mean, just everything. I don't even know where to begin because there's so much in there that I feel like not until you work with it and integrate a camera or LiDAR or, put the batteries in the receptacle and they lock into place. We just spend an excruciating amount of time and effort and just making sure everything's perfect. So I can't really call one particular thing to mind because there's so much in there that we've really spent a lot of time on.
Well, we've got, I basically went into the warehouse and stole this one off the floor. We had just got these, I think, a day before yesterday, maybe, Bobby. We had just got these. So
nice.
Definitely that,
nice.
Listening to you explain that today, that we had a little bit of tight, we had a little thing, and there was definitely some work on your end to make that happen on the next rendition. This is again the nice thing about, I wouldn't call us small company, but we're not making 500 of these a week. You can
call us a small company. That's not offensive. Okay. That's not offensive at all. It's I think the thing to realize too is like the larger heavy lift drones industry is not. It's not like you're selling thousands upon 10,000s of these. At least, we're not. I mean, we work with some of the largest telecom companies and power companies and stuff out there, and they're buying 5 at a time, something like that. It's not like, where they're buying 4 or 5 dozen at a time. So that's the cool thing. Like we're just scaling at a comfortable pace for us. And what I really love is the fact that we get to work with talented individuals like yourself or our other customers. So far, customers have been so great with providing such great feedback. And especially because we're doing all of our own software. You guys got your first drone and you said, hey, this is probably a little too responsive for us. Okay, no problem. So within 2 days, we threw in a button where it's on the software, just a software update to where it's select the responsiveness, slow, medium, or fast. And so now we created that. And I still think that slow is too fast. So I think we're going to put in super slow. And we can do, we can put in anything that we want. software-wise especially. And then also as well as these cameras and these gimbals are being released under the correct MAVLink protocols, we will basically just be able to enable gimbal and camera support with a software update. So they basically just plug it into the drone. We've got all the power ports, all the data ports set. Just hit the software update button, and then magically overnight your drone now supports a certain camera, a certain gimbal. So that part has been really exciting, is to be able to play in the software side too.
Yeah. So Jace, I was going to tell you, just see if you can find me a close up of one of the payloads we were working on. So let's talk a little bit.
I can do that.
Yeah.
Give me a moment.
Yeah, you got a moment. So as far as the payloads go, and some of the stuff you can throw on the bottom, we've already talked a little bit about the cinema stuff. That seems fairly easy. Gimbal, camera, HDMI feed. Not much control that you're doing with the camera. LiDAR in general can be fairly easy as well. They are usually a standalone unit, only require basically the ability to have the drone provide power. Usually it's nothing more than that. But when we're talking about a payload like this, what we're looking at here is the ICI inspector payload. It's got an optical camera on one side, a FLIR camera on the other. Up on the top left, you're running through their SCM, as they call it, their sensor control module, and that control module plus the gimbal, basically, there you good shot of it there. That has to all talk to your machine, and that is basically stuff that you're working on right now, programming via MAVLink to control or talk to their SCM, which then controls and talk. Man, there's a lot of stuff going on here, Bobby. A lot of stuff, So
yeah,
I mean, to be quite honest,
it's a lot, but it's not. Yeah, it's well, all I can stress is that hey, if a gimbal or a camera manufacturer sees this, all I can stress is that everybody play by the protocols. Just design your product to work with MAVLink protocol, and it will work. Basically, it will work. Mm-hmm. So I've got some gimbals and some cameras that we've been testing along with your team out here on the bench with some prototype firmwares, and everything's working really well. And we're super close to announcing the support of all that, but it's basically just some of the most popular, DSLRs and RGB plus IR cameras out there. And so I do believe we'll have more plug and play cameras and gimbal support. But I think the thing that also makes this drone stand apart is that we allow the mounting of just about any payload to it. So in all honesty, I would say more than half of our customers buy the aircraft from us and put on just some payload that we've never flown before. A signal generator, an amplifier, a radio scanner. They'll use it for cargo delivery, and I mean all sorts of applications that don't require a camera. So we're getting a lot of customers coming to us to do multiple all sorts of different applications that are not just camera specific. So I think that's really interesting too.
Mm-hmm. Well, since we're kind of on the payload stuff, and we'll talk a little bit more about this, because we have a lot of stuff that's coming down the pipeline besides just what we've seen so far. So for an example, I've got Rock Robotic that is sending me an R2A, basically their LiDAR as well as a camera that's going to be able to do. We're in hopes of we're going to be putting it on the Prism, but the X4 version, so the quadcopter version.
Nice.
It should be a small enough payload, I think, Bobby, that'll be easy to handle. 1.7 pounds is I think it weighs. Correct me if I'm wrong.
Yeah, that's perfect.
I'll let Harrison get upset at me if I put the wrong specs out there. But don't forget, by the way, a selfish plug, to join us tomorrow with Rock Robotic to continue our Tech Week. So don't forget about that. But that's one payload, Bobby, we're expecting to put on there. A mapping payload, maybe, if we're, as we're working on, other things, to have a mapping, a nice high megapixel camera that can do some high definition and do that. And then I'm just going to get right to Casey's question. Basically, with the move towards the MAVLink connections, do you plan to allow for connectivity of custom payloads or more along the lines of OEM payloads? So when you're going into the MAVLink, you kind of alluded to this already. Everybody needs to get under that same umbrella, the same protocol, the same standard. Do you plan on allowing more connectivity with this? I know you've already working really hard to do that with these manufacturers right now. But what does the future look like as far as, the sensors that you're going to be carrying around.
Absolutely. I mean, the way in which it all works now with Pixhawk is if you get any sensor, camera, GPS unit, anything at all, as long as it speaks via MAVLink and it's implemented correctly, it basically becomes plug and play, just without us as the manufacturer having to do anything. So especially if the settings and such are already in ArduPilot and already in PX4 and all the MAVLink commands are already in there, it basically becomes plug and play. So what that allows you to do is that allows you as the customer to have the freedom to put anything you want on there. Like as long as the sensor is supported over MAVLink, you can just plug it into our drone. We give you access to MAVLink, the physical connections like up under the canopy, and we also give it to you in the back of the drone with a waterproof, dustproof connector. So you could plug it in like a gimbal or a camera in the back, or you could plug in like an onboard computer of some sort under the canopy. So as long as it supports MAVLink, it gives you the freedom to put in whatever you want. And then it makes it even easier for us as the manufacturer, because what we do is we just get it talking, and then we fill in all the settings that we deem are appropriate for the use of that camera and that gimbal. And then we just implement a few buttons and it's done. So that way it becomes plug and play, to where you throw on the gimbal and the camera and you select the profile of what you just loaded, and now it's a plug and play system. So I think right now it's kind of a growing pains for some people, for some manufacturers, especially like these camera and gimbal manufacturers. But what that allows it to do in the future is you're going to see a lot more collaboration and a lot more products just being able to work with the system. Like I spoke with a parachute company the other day where they followed MAVLink, and it's plug and play. So we could put their parachute on our drone tomorrow, and we now have a plug and play parachute. Done. Where if you don't follow protocols, we as the manufacturer have to hack your software into our system and then offer a software update. Where basically if everyone just follows by MAVLink protocols, it just becomes plug and play.
That makes sense, and that's probably the, like I said, creating that protocol, creating the ability. So hopefully that answers your question there, Casey. I know there's a lot of manufacturers that do kind of struggle with this. They have their own protocols, they have their own SDKs, they have their own stuff that they want to do. But even Phase One, a very sought after camera manufacturer that everybody always talks about, the Lamborghini, the Aston Martin, whatever you want to call of cameras. They as well have created a pathway to go into the MAVLink, into basically a Pixhawk, and try to get that going. So might be seeing that real soon, Bobby, of a Phase One integration. So that's what we're hoping to see, is these guys go ahead and take that upon themselves to try and figure it out. Otherwise, as Bobby said, you have to he's got to hack it, he's got to figure it out, then send it out to the masses, which can be, as we know, firmware updates are not always the best, as it's trying to make it work, if it's already worked with. One more tech question for you that's already come through. So how much wind, I haven't put it in a lot of windy conditions, Bobby. I don't know if you have, but, realistically, how much wind do you think it can handle, considering like what payload it has, what the size of it? You probably have two different numbers for the 4 and the 8, but how much wind can it handle? Wyoming being one of them, where there's a lot of places we can fly, and it's super windy in Wyoming.
Yeah, I think the wind question, we've been analyzing this a little more. The wind question is kind of a loaded question, because it's, at like, what are you asking? Like at what wind speed can the aircraft no longer hold position? At what wind speed will the gimbal no longer be able to focus on an object? At what wind speed is it unsafe to fly? So it's a loaded question, but in our testing, we've been testing this at around 20 to 25 miles an hour. It starts to get like, whoa, it's getting bumped around up there. A consistent wind to me isn't too scary. It's more of a gust, which is scary, because then it wants to pick up the aircraft. But from what we've seen with Prism in our year and a half now of testing, I would say anywhere, once it starts getting above 20, we start to keep more of an eye on it. But anywhere below 20 miles per hour is just fine.
Yeah, definitely has the strength to push through. I've definitely been in situations where it's windy enough not to hold GPS on a very agile ship like an Inspire 1, and it's
sure.
It's moving away, and it ain't because it's lost its link. It's just it's
Right.
listing to that one side. So great,
And that's
great
scary.
factors there. Yeah. I got a picture of it in our office of it sideways, and people are like, "That's a really cool maneuver," and I'm like, "No, that's just landing. That's it's trying to land in the wind." So. Well, any of the other stuff, like I said, we talked about the mechanics of it. We've talked about the possibilities of it. We've talked about the payload integration. We've moved into basically, these complexities of getting manufacturers to kind of get on board. Kevin, did you have anything else to add as far as just general conversation here? I don't have as many questions as expecting. Guys, throw me some more questions, and don't ask me what conditioner I use or what Kevin uses to shine his head. Just keep those two. But anything technical, if you guys have any other questions, please do so. But anything you wanted to add, Kevin?
Yeah, thanks, John. I think this is really customer focused in terms of who should be considering this platform, and I think there's some obvious and maybe not so obvious solutions as well. So obviously, if you're any kind of a researcher, especially with the M600 now end of life. To me, this is the optimal platform, right? So you've got standards that are clear that you can work on to integrate. You've got a ton of payload flexibility. The modularity will allow you to configure it for multiple projects. And the big thing is you have North American support on the same time zone. And just to give you an idea, one of the things with the user manual. It's the best one I've ever seen. It blows it away. It's fantastic. I think it was 129 pages. So lots and lots of information. So that's number one. Number two, if you are specifically in some kind of emergency or response scenario and you're looking at, building a prototype, or you're looking at, getting multiple units of the same configuration where you want consistent parts and everything like that, you may want to have the ability to swap out payloads. That's when you want to look at it. And so one of the things that I think is really, really important of this platform, and MAVLink in particular, is when you compare it to a product, the market leader in the medium-sized space, the DJI M300, and DJI has a pretty robust ecosystem of what they call the PSDK, plug-and-play payloads. Well, the challenge with those for emergency scenarios is every time there's a firmware upgrade, a big chunk of those are bricked. And so sometimes they get fixed fast, sometimes it takes a long time. So in my mind, that's the number one biggest weakness of the DJI platform for non-DJI made equipment. And so it's not a huge deal all the time, but if you're dealing with an emergency where you can't afford to have your speaker or a certain sensor not work, you can't afford to be getting bricked during those kinds of updates. So for things like that, as we start to see integrated packages being built into the Watts platform, that's going to be very important. Where much like you don't have the no-fly zones, you also don't have to worry about not being up and running on all your sensors. So I think that is a key area. And one of the things that we're doing with RMUS to work with Bobby is also developing some of these specialty payloads. John mentioned the inspector, some of the public safety stuff that we're working on and we'll be announcing on. And that's great because John's team in the US and Fraser's team up here, we have what I think are the best technicians in the business in terms of integrating and supporting some of these payloads. So if you're looking at that, that's a great way to consider this platform as well.
Very good. Well,
thank you, sir. I agree with you too. I mean, if I can just jump in for a second, I think you guys nailed a lot of. I think you nailed a lot of great points, and I can just say that from what we've been seeing from our inbox is just a lot of companies who can no longer fly DJI products, and they are looking for an American-made solution. And while we're still using some components that come from overseas, it's designed, assembled, supported, and test flown and everything here in the US. So we are getting a lot of hits from customers who are looking for something because their M600s they can no longer purchase an M600. So I feel like Prism's really a good fit for a lot of these various companies, whether they're doing mapping, surveying, LiDAR scanning, flying anything around. I can't get over the number of people just flying just anything. I mean, we have companies calibrating like military level satellite dishes using our drone, and cargo hauling and package deliveries and everything like that. Like there's so much that people are just doing with these aircraft that I can't even keep it straight anymore. One of our customers out in Montana, they're just a great group of guys. They use this for water sampling. So they drop a capsule in the water and sample the water like at a depth of 800 feet or something like that, and then reel it back up and fly it off to scan it. So there's so many different applications that I feel like as the industry matures and as these plug and play payloads become available, I think that this machine will really be popular for people who are just looking for an all around really flexible platform, but that's really easy to use, just with the same user layout and simplicity as you're used to seeing with DJI or any other product like that. So that to us is what we aim for with Prism.
Excellent. Well, you want to take a close up at me there, Jace. So we have the remote here. You know, this is one of the remotes that comes with the Watts ship. We just have a question here from Jason. Can you speak more regarding the software on the controller? What does it come with, and what can run it? You know, so what does it come with? What can run it? That's kind of the question here. And like I said, I just wanted to give people, if they haven't seen it already, you know, the physical size of it. Ergonomically, nothing terrible. You know, thank you, Jace, for coming in on that. Nothing bad. It's got a great screen, you know, as far as being able to see your inputting and having video feeds come through, as well as having our, you know, any of the telemetry data coming through. So overall, just a great unit. You know, this guy. Now I don't want to allude to any changes or anything like that, but you know, as far as this unit goes, very good. And I can see Bobby's got a screen shared on his, so he can kind of maybe talk a little bit about it and the software on it. So let's talk about that. Thank you, Jason, for asking that question, so we can talk a little bit about it. So back over to Bobby. He's got his QGC pulled up on his screen.
Yeah, absolutely. So we're using there's a very popular software out there called Q Ground Control, so QGC. So what we've done is we've forked that ourselves and made Watts QGC. And what we've done is we've implemented a lot of nice pleasantries in there and implemented some custom things that we felt were necessary to make Prism the best user experience possible. So this is it fired up in the office. So, you know, we don't have GPS or anything like that. But as you can see, just, you know, a general, easy to understand layout where it shows you altitude, your battery voltage, how many milliamps we've consumed, allows you to switch between an FPV camera or any other auxiliary camera that you would plug in. And we've done a lot of nice things in here. So you can go ahead and we have a pre-flight checklist in here that reminds you of everything that you need to do before you take off. And we even have one where you confirm that you've got the right to fly in that airspace. And by doing that, we don't need to do any geofencing. So this one right here, if you click that airspace, that allows us as a company to not have to do geofencing. So you can fly this drone anywhere. So we've done this in there. We've also even gone in and created our own menu, which you can take a look here. This is our Prism menu inside Watts QGC. And this allows you to even update the firmware of the drone itself all through the app. And the app itself can be updated. So it really allows for some flexibility. We're even tracking the flight time of the aircraft itself. In addition, we're tracking the flight time of each individual propulsion system. So, this screen and this app just really allows like a super easy, intuitive user interface with the product. We do get a lot of requests to run UGCS or any of these other applications, but for right now, we're just recommending to run Watts QGC on the handheld radio system itself. And then if you need to run UGCS or any other application like that, we just recommend a separate radio going to a separate tablet or a separate computer or something like that. But this allows you like a really easy and powerful interface with the product. It allows you to do waypoint missions and your flight planning. I'm trying to scroll through it here. Trying to, you can program. Here we go. Here's one. You can program like a survey or a grid, anything like that. Pop in waypoint missions. You can do all this by the app. So it's very intuitive. It's very easy to use and just super powerful.
Awesome. So basically, the one thing about it, as far as like the software itself, very, as Bobby had mentioned, very easy to understand. It's not very complicated. He's even made it more simple than what is mostly available out there on the open source stuff of Q ground control. So I'm pretty happy about the way we've been messing around with it and flying it and kind of handing it over to customers. So this is the next question, which is a great question because we've already sold a number of units out there. I know you have, Bobby, have had some units out there, obviously, with all the people doing the fancy stuff they're doing so far. But one of the questions here from Adam, are the aircraft being made to order or is there inventory in stock? And I just got a stocking order back in of our Watts birds, but you're not really doing them, custom made, but in a sense you're making every one, on the bench. You said you had 5, being assembled and put together. So what is that production looking like right now to get myself, units and then get them out to people like Adam?
Sure. So our previous generation aircraft, our MFD 5000, were all made completely custom, one-off, built to order. And with Prism, the goal was to make one machine that we can build to scale. So we are building Prism in batches of 1 to 2 dozen at a time. And while I would like to say that they're in stock and on the shelf, I just can't seem to catch up. So we just build more and more, but then they're pre-sold by the time they go out the door. So one of these days, maybe we'll have some inventory of them just sitting here. But to date, we don't spend a cent on advertising, and all we do is just put our time and effort and all resources possible back into the product to make it as good as we can, and just ordering more parts. So I will say that trying to get the raw goods in-house during, as the pandemic kind of eases up a little bit, but the supply chains are just nuts right now. So it's super tricky to get parts in-house, but I will say that once parts come in-house, we have a machine turned around out the door in about 5 days. So I do think we can scale with this. I think at some point we would be able to do 100, 200 units a month if we wanted to, even in our smaller building here with the right build crew. But it's we're just trying to catch up right now to the demand. So it's a great problem to have. But right now, like a lead time is about 60 days. So it's not too bad. By the time you're ready to go with this aircraft and we send it out to you, we notice that customers in general take 1 to 3 weeks anyway to receive it and go through it and, get their sensors ready and get their insurance and their waivers and everything set up. So it's about a 60-day lead time now, but one of these days we're going to have inventory. That's the goal.
Backstock. You got to have backstock. But
one of these days we're trying, man. Just, we can't catch up. We order stuff and then you guys put in a big propeller order and something else, and so we had stock, but then we don't. So it's good. It's good.
Well, you bring up a good point, not knowing about the sourcing issues and problems. Everybody's kind of facing that in the industry right now. I think everybody's having a little bit of crutch and trying to figure out, after this pandemic, by the way, I have a whole bunch of lumber apparently that's worth $1 million. If you have some, I'm just kidding. I've seen this thing. Yeah, it's worth gold right now. So we've got about 5 more minutes. I've got a couple more questions. We'll just kind of hit those off. Sure. Kevin asks, is the aircraft being used in the oil and gas industry, and if so, what type of inspection? So do you have any specific oil and gas customers that have put a payload on there? I know we've been working closely with ICI. ICI is trying to get an OGI set up on there. I was actually just in another school the other day, and I saw not a Bobby Watts bird, but I saw another bird carrying around OGI, and that's all they were doing is methane gas detection. So, what have you seen out there as far as people using the Watts Prism?
Yeah, as far as OGI, in just historically, I don't think we've had one customer ever do OGI inspections with our drone. But I know that as we were talking, one of your customers is interested in the ICI setup. We're seeing some other OGI sensors from companies like Workswell and others. So I don't personally have much experience with it. Seems like a lot of our customers do LiDAR or mapping, a little bit less OGI, but that's it's definitely an industry and a need that we don't see going away. So if we can get into that, then we're definitely interested.
Yeah, I think a lot of the times that we get people that ask about oil and gas, they sometimes it's kind of assumed that they're going to do an OGI camera, but not always. I know a lot of companies have just put methane detectors. Like I said, I was over at this other spot and I saw just a sniffer box on the bottom of an M600. That was an inspection, flying low, it wasn't up high at all. So there's a lot of things that we can definitely do in the oil and gas space.
Sure.
So let me see. We've got one more question here from Adam. Does the Watts QGCE have swarm capabilities? Can I fly more than one Watts bird at a time, Bobby?
Not natively built in, but once again, because this is built around open source software, you need to just Google, does ArduPilot support swarming? And if so, then yes, it will work with our aircraft. So we don't natively support that or support the use of like one remote can operate multiple aircraft, simply because we've never really had that much of a request. But because there's so many things you can do with ArduPilot, I'm probably 99% confident that we can make these things swarm. That would be cool. That'd be wild. That'd be a lot of payload in here. That'd be awesome.
I'd love to see that. Like you said, any type of any challenge like that, it's a challenge. So I'm ready. Like, oh, Bobby, do this. Bobby, do this.
For sure.
That's cool.
Man, I can't wait. We are working on such cool projects right now that I can't wait to share, like, with the world, like some kind of custom stuff. It's just so ridiculous. It's like the most ridiculous things you could, like, the most ridiculous requests that customers have ever asked, and somehow, like, we're doing it. So it's cool. So hopefully we get to share some things by the end of the year or something. But John, I know you'd be stoked on some of these. So
I love it.
Pretty wild.
You know me, I absolutely love it, messing around with it and playing around with it. So, trying to figure it out, seeing what people come up with. I think it's fantastic. So a segue, I mean,
For sure.
I don't have any other questions. Well, I've got one more. Jason, any obstacle avoidance systems on the Prism? I know currently you don't have obstacle avoidance set up on it. Most heavy lift don't. Not that they need
Right.
it or shouldn't have it. It's just that the majority of the heavy lift that I've seen don't have a level of obstacle avoidance. Maybe something in the future. I don't know. Is it possible? Do you need to? That's always a question. There's a lot of people that fly in some sketchy places, and obviously, when you're flying an OGI, you're putting almost 140K up in the air. So, would obstacle avoidance be something on the roadmap at all in development, Bobby?
Yeah, it just depends on our customer demands. I mean, like I said, like in the very beginning, we're trying to catch up and hit the ground running as fast as possible, and we're just trying to hit the items in the order of importance that we see them. And so I would put obstacle avoidance somewhere down, I don't know, maybe issue number 20. Like issue number 1, like primary directive number 1, don't fall out of the sky. Primary directive number 2 is make an aircraft that's very easy to interface with, like a very nice user experience. And that's what we've been doing. And so something like obstacle avoidance, we can do that. There are plug and play obstacle avoidance sensors with ArduPilot that we can link people to. You just have to mount it yourself and basically set it up. But right now we're not supporting that. But if I had to guess, in our next generation of products, we'll probably do at least one, one sort of sensor for obstacle avoidance, maybe in the front. But it just depends on the demand. Depends on the demand and feedback. And primary directive number 1 is not trivial, by the way, sir. That's very
obviously there's a lot of ships that have been struggling with this primary directive number 1 of not falling out of the sky. So we've already experienced that.
It's so hard.
Many a times, So I get that.
It's so hard. Like, it's so hard. Like, I wish I could explain the difficulty of, like, there's a component where if I put it in your hand, you wouldn't even be able to see it. And we had some circuit boards come in with the the mixed up component of the component that if it's in your hand, you can't see it. And it like we plug power in and it immediately like blew a trace somewhere. And it's like, what? Like I can't even see this part, but yet it smoked a board or something. So even just manufacturing it and getting it to the point where it's flying really well is just incredibly difficult. So the cool thing is it humbles us every day. It's just amazing, but it's exciting. Like it's really exciting. So by the time they go out to you guys, they are very well tested, very well. You know, we still manually fly every single one. We test them all, and yeah, I think we'll be doing that for a considerable amount of time just to make sure everyone that goes out is perfect.
Yeah. Well, I mean that's pretty much our time, but I did want to mention that, you know, as far as our relationship between, you know, RMUS and Bobby, you know, we've got a product specialist that is now assigned within RMUS staff. You know, he's one of my greater techs that I've had for the longest time, but we're moving him, transferring him over instead of doing stuff with a lot of the DJI or anything else. You know, he's concentrating heavily on doing payload integrations and being that specialist as far as RMUS goes. We want Bobby to definitely take care of what he can on his side, but we definitely have a responsibility as RMUS to make sure that we're also doing our due diligence to make sure that the people that are buying from us are getting a really good product. So making this product specialist, creating this position, making sure that, you know, when you guys call, you have tech questions or anything like that, you can talk to that person that's kind of specific to the Bobby Watts Prism line, as well as any of the payloads that we're going to put on there for special types of stuff we're putting together. Well, one more time, let's put all three of us on the screen. I wanted to thank everybody. Bobby, I can't say enough about our relationship right now. Kind of working on getting you that feedback, helping you out, listening to the people out there, you know, working with your stuff. Any chance you're going to be on the road soon? I mean, I know you just said you're busy as hell. You don't want to spend a lot of money on marketing. I totally get that, man. Put the money in the funds into the development and creation of your product, but you know, at the end of the day, is there anything that you're going to be kind of showing off here in the next little bit? You know, physically, shows, you know, planning on attending anything?
Yeah, I think depending on what happens with, you know, as long as things are staying good with COVID, then we're scheduled to be at AUVSI later this summer, and then perhaps Interdrone or commercial UAV show. I don't know. Probably I've hit those three in the past, and those three shows alone were really great. So long as everything in the world is okay, then I would love to be there. That would be really great. And once again, thank you guys for all of the feedback and the support and the help so far. So I think if a customer decides to go with Prism through RMUS, you know, they're getting the support of you guys and all your crew. You guys can email us at any time. And, you know, customers can reach out to us anytime, and we try to answer emails just as fast as possible and tech questions. And as Kevin alluded to, our 100-and-something page manual, but we have a nice 15-page quick start guide as well. So we give you the here's the basics that you need to know to fly, and then here's everything you'd ever want to know about having the aircraft. So we try to give you both. So just thank you guys again. It's been awesome working with you, and I look forward to a continued excellent relationship. It's been awesome so far.
Awesome. Kevin, do you have anything else to add before we wrap it up here?
Yeah, just a little plug. We will have the aircraft in Canada. We would have already had it already, but John's team has been hogging it. So it will be up here available for when we're not locked down to let you have a crack at. And then the last thing I'll just like to add is I really love this product because to me it is the epitome of RMUS old school, right? When the organization started and it was building these great systems on the M600, and they would just be lined up and the customers would sort of dictate when on there before we got advanced. And it's great to have all the plug and play and everything like that. Don't get me wrong. But this is the core of RMUS, building the stuff to the needs of the customers and moving out there. So it's exciting. So thanks, Bobby.
Yeah.
Absolutely.
Excellent.
Thank you guys. It's been awesome.
Well, thanks again, guys, for joining me today. Kevin, as always, my partner in crime when it comes down to this, and then as well, Bobby, thank you for being on the show today, kind of explaining a little bit more about the Prism and capability. We really appreciate it.
Cool. Thank you guys so much for this opportunity. It's been great, and look forward to speaking with you guys soon.
All right. Well, let's close it up here on this episode on our ARMUS Tech Week. So this wraps up basically day 3. We still have 2 more days of Tech Week. Tomorrow we're going to be talking to Boston Dynamics at 10 a.m. and Rock Robotic, which I had already mentioned that basically Harrison Noel will be here explaining a little bit about LiDAR, so you don't want to miss that if you don't know much about it, what it is, how it is. Also talking a lot of the other systems out there. What does it mean to compare it against an L1 or an R2A or Phoenix and all these others. So don't miss out on that broadcast tomorrow, as well as the Boston Dynamics. Kevin will be definitely helping us out with that one at 10 a.m. with Boston Dynamics, 2 p.m. Mountain Standard Time with Rock Robotics. Then the following day, to finish up and close out Tech Week with ARMUS, is Skybrowse. So we'll hear a little bit more about Skybrowse and some of the stuff that they're working on, 3D modeling, quick 3D modeling. So don't forget about that. As always, if you have any questions on the Watts Prism, any other questions on payload integrations that we're doing, or any of the systems that we're putting out there, make sure you get a hold of us here at ARMUS, sales@armus.com, and any of your training needs, if you have any training questions on any of these platforms that are out there, training@armus.com. Thanks again for joining us. Hope to see you guys tomorrow or even the next day and hanging out with us at Tech Week. Thanks again for Bobby and Kevin hanging out with me today. We'll see you guys later.